Professeur Pejman Mirza Babaei, c'est à vous. On l'applaudit bien fort, mesdames et messieurs.
Good afternoon, everyone. My name is Pejman. I'm an associate professor at the University of Ontario Institute of Technology. I've been basically following the amazing work my colleagues are doing at Tech 3 Lab and this awesome conference for the last few years. It's my honor to be invited to give this presentation here, so thanks so much for the invitation. I'm going to talk about user research methodologies. So I'm not a designer. I'm more on a research side, or the user research side. And I'm going to, thanks, yeah. And I'm going to talk about games. I don't know how many people here consider themselves as game developer. Probably not many. But what I'm going to talk about is basically on methodologies. So most of this stuff are applicable to evaluating any form of interactive experiences, I would say. And I decided to go over a collection of projects that we did in my lab to kind of give you a flavor of the type of work that we are doing. And if you want more information on any of these projects that I talk about, I would be more than happy to share them with you. So a little bit about myself. So I did most of my education at the University of Sussex in the UK, Brighton. It's an amazing place if you've been there. My PhD was very unique, the way it was set up for the time. And I think it's quite actually similar to what students do at Tech 3 Lab. So it was doing the studies, reading the papers, but also applying everything that we were doing on commercial projects. So we basically had a spin-off company there who provides service to game companies across the world. And that's where I did most of the experiments that I used in my PhD thesis. As I was finishing my PhD, I worked at a company called Player Research. And we basically, the service was doing user research for game companies. So in the 4 or 5 years that I was there, I think I worked on more than 25 game titles, so commercial titles. And my focus was to apply what I learned as part of my education on these games. So there are some of these titles that are quite dated by now. But if you are a gamer, you probably have heard of these few, that these are big games at the time. So in 2013, I got a position at the University of Ontario, moved to Canada. And I was quite fortunate because I had an opportunity to work with awesome guys at Execution Labs in Montreal. And what we did, or what they did, they provided financial support for small indie companies to develop their game. But it wasn't only the money that they gave them. They also provide some expertise to help them develop better games. And my role was a UX research director, so to help all these around 20 companies with their UX research needs. And during my time at Execution Lab, I think I worked with around 15 companies. And these are some of the titles, like the PewDiePie one, probably one of the most famous one that you may have heard. So basically, everything I do in my lab and with my students and with my research are motivated by these experiences from working with companies. And basically, I called my lab Applied User Research Lab. So everything we do is more on like a research and development for applying these methods to games under development. So my focus, as I said, is on formative evaluation. That basically means I'm looking to evaluate products as they are still in development. And the intention is to figure out what can we tell developers to optimize the experience they want to create. And there are some characteristics here that it's super important, and it came up in other talks. So things such as representative. So you need to make sure to recruit representative users. You need to make sure to run your studies on representative platform. And these are important. You need to, when it comes to basically commercial viability of what you are doing, we need to focus on timely. Like if we're running a study and it takes us a month to analyze the data, that information not going to be useful for game developers because the product moves really fast. If we are running a study that costs loads of money. That's information that's going to be beyond what the developers can invest. And more importantly, and that also came up in the previous presentation, we need to be able to motivate the developers to believe in what we've done, to persuade them to make them listen to us. Because if we cannot convince them to modify their product, basically, even if we do the best study ever, nothing going to change in the product, and it's all our effort would be wasted. So a lot of my work, as you will see in the future slide, basically focused on how we communicate the information to developer in order to make them believe in what we have to basically tell them. So I have a little diagram, and this is one of the study I was doing. This is mostly like playing with different user research method. And I wanted to highlight the issues or limitation with self-reporting techniques. And self-reporting techniques, as you probably know, are techniques that rely on the participants to tell us how they experience let's say, the game in this case. So I gave participants a blank sheet of paper. They played the game for half an hour, and I told them, can you draw how you experience this game? And these are the two examples of what I got back. So on the top, the participants felt, I guess he was enjoying the game until he realized he's going to win the game, and then his enjoyment or experience kind of declined. The one on the bottom, that's the most detailed one. So there are 3 distinct events that the participant could remember. And this amount of information, although it's interesting, but they are not necessarily very applicable, very useful. So what do I tell the developer to fix? So if we are relying on techniques that only get data from what the participant tell us, there is an opportunity that we miss loads of useful information. So the challenge in game development, and I always tell my students that if you understand how to evaluate games, you can evaluate any other product because they are a very complex system. So one of the big challenges is from the pool of user research method that's available to us, what method we would pick. So that idea of mixed method. So what method we would pick to answer the question that developers are trying to ask us, or to answer the experience, to better understand the player's experience. So again, the idea of mixed method. So what I mean by mixed method, I have a bit of video to show you. And this is an example of our observation setup. So we would basically have the game output, so the video you see. The green dot, it's the participants' basic eye tracking information where they are looking at the screen. We have the participant sitting position, and many studies talk about how that may indicate if they are engaged with the experience and if they are not. We have the monitor looking at what buttons they are pressing on the controller, and we have the GSR information. And I think, although the presentation was in French, I think Pierre-Magic talked about GSR in the presentation earlier. So that's the indication of arousal, which could be excitement or frustration. It's quite difficult to tell them apart just looking at the GSR data. But all of this together, this kind of give us a lot of information on what's going on to players, where they are looking on the screen, what's happening on the screen, which button they are pressing, how their body is reacting to the game. And we are trying to basically triangulate all this information together in order to better understand what's going on and what we can improve in the game. So back in 2011, I did a study using GSR, but for those of you who use these signals, they're really complex, they're difficult to analyze, and not necessarily quick to apply to formative evaluation. The way I adopt them, and it's kind of going to that mixed method idea. So I looked at the events in the game that we were testing that caused changes in the GSR level, and I indicated those events for a post-session interview. So rather than doing the post-session interview, just asking some random questions, in most cases, we were able to structure those interviews with the events that caused bigger change in players' arousal level. And then in this study, as I said, in 2011, we showed that using this mixed method approach, we were able to identify more issues with the game than just relying on observation only. One thing I noticed from working with developers in our office, I noticed when they see that the player's body react to the events in the game, they rely on those data, they trust it a lot, and they take action on those. So I had this idea, and that's basically the basis for my PhD, And the idea was, how about we use players' physiological measures to tell the story about their experience? And we call that biometric storyboard. So we basically tell the story of how players experience the game using their biometric data. So as you could see on the top, we basically draw those lines based on GSR, and then we try to map them to the events in the game. And in that way, we could basically tell developers that in part 1 of your game, the players had negative experience, and that was correlated with the interview comments that they had. And it would provide them with a really quick overview of what happened in the game and what areas they could focus to improve. We further on developed this approach more. So we looked at adding EMGs, so looking at basically facial muscle as an indication of happiness, smiling, or frown as like frustration. And then we tried to build a tool that could gather basically players' comment and then connect them all together on one graph. So what we could see here on the top, we have the GSR data, the green and red line. In the middle, those are activation of EMG signals, and then the red and blue dots are where the players made any comment, and they are all kind of overlap each other in that level. So what we realized there, we were creating these graphs for individual players, and although it was very effective, but it was also quite time-consuming to create. So we decided to find a way to try to combine more of these information together, and we try to add more data. So in the picture that you would see, and I'm going to zoom in a second, this is an example of a Mario level, and we are collecting players' movement data, and we try to color code those lines based on their GSR value. And you could see here, for example, a bit of a zoom in, like we have these little bits in the middle that it's quite a safe section. So there are not tough enemies, there are not much of opportunity to fall, and you see that players are experiencing lower level of arousal here, and you could also see the paths they take. And again, this is about mixed method and how we can triangulate these data together. However, if you look at kind of towards the end of this image, you see that there is a slightly stronger enemy there, and there are two gaps, so there is an opportunity for players to fall, and you see that their signal shows that they were experiencing higher level of arousal. What's important in my work is I'm not trying to say if this is a good design or a bad design. As I said earlier, I'm not a designer. What I'm trying is I'm reporting back to developers that this is how players experience your game. Would this match your design intent or not? And again, like this was quite interesting towards end of level, that you see there is a big jump to do, and the data from the player movement shows that none of the players failed this jump, but they still experience higher level of arousal. So they basically perceive this as a difficult challenge, but they all managed to pass this challenge without failing. So these are the type of information that this triangulation of movement data and physiological measure can provide for us. So as I mentioned earlier, throughout my career, I became more and more interested in working with smaller companies and in the developer. And again, the stuff that I talk about here can also translate to small and medium-sized industries because they share similar challenges. One thing is interesting about the game industry in Canada. We see most of the Canadian game companies belong to basically a small and medium size. So more than 80 or actually 90% of companies in Canada, game companies, they are a small and medium size, so less than basically 500 people. The other interesting fact about Canadian game industry is that the industry keep contributing more and more to the Canadian GDP. So we are basically making more money. And in the research report that Electronic Software Association of Canada published, you see they also talk about the resources that's been invested in creating those games. And one thing which is quite interesting is from 2015 to 2017, that's where this data are from, basically we are spending less resources, but we are creating more money. And this is quite fascinating to me because that basically shows the impact of technology, the impact of ways that we are doing things in a more optimized way. And that got me thinking that, okay, how can I help optimizing user research process for the small companies? How could I adopt these processes to make them more accessible? And I'm going to give you a few examples on what that means. So for those of you who conducted user research, one of the key methods I think we use is observation. So we basically record what's happening to the users, and then we sit there and watch back and try to figure out what we can fix in the game. You probably, if you've done this before, you agree with me that this is a really time-consuming approach. When it takes time, it's also expensive. So you need a researcher to collect all this data and then look at this data and analyze them. So in order to speed up this process, we are combining those qualitative measures with some quantitative data. So here we are looking at a game that we tested. So that's like 9 hours of gameplay for each player. And then we are looking at how long it would take for player to complete certain level. And then we compare them to what the developer intended. So here we see that in level 5 in this picture, most players are taking more time it takes them more time to complete that level. And when we talked with developer, they said, yeah, that's not right. We need to fix something. But can you tell us what's wrong with that level? It's probably something is maybe too difficult there. So based on this data, then we could look at players' movement in that level. So we have the heat map of players' position and the action they did. So the players got stuck here because we see the position and we see they did loads of jumps. So rather than analyzing 9 hours of video to figure out what's the issue, we could quickly pinpoint that level 5, that's the level that players spend too much time. Looking at the heat map data of their location and then overlaying it with level design, we could identify the exact issue in the level design that could be fixed. So something that could optimize the process from probably 10 hours of reviewing of gameplay data to maybe half an hour of figuring out that issue. And that's where I think this method could be adopted and make more accessible for smaller companies. The other project that we did, and there is a little video, and I hope that the sound would work, I'm going to play. And this is a tool that helps developer to collect data and basically visualizes the data for developer to be able to, again, understand what's going on with the player and make judgment in terms of what they can fix in their level. So I'm going to try to play this video. If the sound doesn't work, I'm going to basically explain over.
Researchers are developing a set of techniques and tools to measure and study players' behavior to provide information for game developers in order to optimize the player experience of their games. One major challenge is the sheer quantity of data that needs to be analyzed and understood. This can often be daunting and confusing to decipher. This requires game developers to painstakingly review often large-scale playtesting data to make improvements to their games. To address this, we have been developing a tool to assist the collection and representation of playtesting data, such as players' in-game behavior, such as tracking their movements, and physiological measures, such as tracking their arousal state. Although various data representation or reporting techniques have already been introduced, most of these techniques only focus on statically displaying large amounts of data captured directly via telemetry without integrating qualitative or contextual data on players' emotional experience. The tool we have been developing is a Unity 3D-based plugin that facilitates the gathering of playtesting data, visualizes this data, and provides an interactive, in-game 3D environment for players to explore and interact with. The visualization can be viewed from different angles. For instance,
I'm gonna pause this, but you got the idea. So basically, that's a tool that helps developers to collect the data from players and then interact with those data. And the tool is available for free. So if anyone interested, I can send them the link to the GitHub repository for the tool. What we learned from doing this project, we quickly realized, and I guess that's again was in one of the presentations this morning, the challenge with visualizing this data, because as soon as we gave them to developer, they tried to zoom out and zoom in, and then when they zoom out, it gets too cluttered for it to be useful. So that kind of motivated the current project that we've been working on for the last 2 years, and that's looking at how do we move between aggregated and non-aggregated data, and what's the best way to to basically aggregate the data and represent that to the player. So few of these visualization that you see, we are basically we are playing between different way of aggregating the data and different visual design for that aggregation. And again, we have few papers on this topic. If that's something that you are interested, let me know, and we can talk about this more. And again, the same technique could be applied to analyzing maybe eye tracking data. In this project that we are looking at, it's looking at players' body movement in a VR setup. So same basically aggregation technique can be adopted for different use cases. We also working on one of the recent projects, and that also got loads of attention from many companies, many game companies. And it was interesting because it kind of relate back to the earlier talk this afternoon, and that's on how we can use AI agents to test our game. So, and that was kind of your question as well. So one of the issue with running user tests or play tests in our case is you need to recruit loads of users, and you need to recruit not only representative users, but also you need to cover a wide variety of different, basically, user profile. Then you need to bring them to the lab. It's going to be really time-consuming. And sometimes, if you haven't polished your level or if you haven't fixed some of the major usability issue before, you can waste loads of time on bringing real users to the lab, but they only get stuck with some basic usability issues. So the idea with this project is we basically program AI agent to play the game like human. And we are not using any machine learning technique. We are basically looking at human factor and basically literature in psychology to see how users behave in certain environment, how long they can remember things, what sort of if they are type of users who want to finish a level, for example, really quick, what sort of behavior they would present in compared to a player type that may try to avoid all the enemies and then just go and collect some resources. So we are basically able to replicate some of these users' behavior and then let them play our level. And based on that, we would identify issues with the level design that could help us iterate much faster. So again, the intention is not to remove players or real players from the process. It's just to provide developers with possibility to be able to test their design much faster. And once they are comfortable with what they have, then they can bring real users, which would be expensive and time-consuming. So this is one of the recent projects, as I said, that we are quite excited about. Cool. So I guess there are going to be a few minutes for question and answer. But I'd like to thank my research team. Obviously, I didn't do this work alone myself. It's been done by my students and supported by ANSERC and other government agencies. If you are interested in user research technique, there is a book called Game User Research that you could check out. And I'll be happy to answer any questions that you may have as well.
That's wonderful. Thank you. This is fascinating as we've heard perspective on how to measure the user experience on more traditional interfaces or more traditional digital experiences or even real-world experiences. And now you're introducing a way to measure and quantify the experience in those highly complex interactive gaming environment. Yeah. What areas of research is about not just the experience through the game, but about how to control the games and all about the interface on how to interact with those environments.
Okay, I'm not sure if I understood your question properly, but if I understood it correctly, I see, although they are very, very much connected, but I see the difference between the design and user research. So most of the work that I've done is looking at how can we better collect data from users, and how can we better analyze the data, and how can we communicate that data to designers. And again, most of these are a small kind of R&D project that would have application for companies. I've done some work in terms of user interface design, which obviously I didn't talk about them. But I actually have one slide. I see if I can show it to you guys, because this may kind of talk about what you, oops, no, it doesn't work like this. Okay, here we go. So this might be something that relates to the question you asked. So one of the projects that we have, and it's on UI design, that might be relevant is this project. We call it the fall of the fourth wall, and we are looking on how we can make a spectator better interact with players in like an e-sport format. So think of a movie Hunger Game. I don't know if you watch it, but think of it as a video game. So how a spectator can influence the gameplay for players, and what sort of interfaces that we could provide for them, or what sort of interaction we could provide for them so they can influence the gameplay for players. And this is quite interesting, because when we think of novel interfaces, then we also need better way of evaluating. So that's probably, I think that's your question. So new interfaces, new way of interaction would basically warrant the need of more, let's say, evolution in how we combine user research method to answer more complex questions.
Jurka, I invite everyone again to ask questions on sli.do. What kind of, you highlighted the types of size of game publishers and the fact you enjoy working with the smaller players. How can those research projects become the standard, the de facto way of testing games and developing games with all all game publishers?
So most big companies, big publishers, they would have a very big internal user research team. I guess like Ubisoft in Montreal, probably you guys are familiar with. I think they have more than 20 user researchers in their team. And their job is basically not only conduct the studies, but look for new ways of collecting data. The issue there is most big companies, they see it as one of their basically IPs. It's one of their assets on how better they conduct those evaluations. And they usually don't necessarily share those information with other people. And that was the direction that I took in my research a few years ago on how can I make things that are more accessible for studios that don't have the resources to invest in these work. And most of the projects that I did are all available open source. Even the AI project that I talked about, it's available online if anyone wants to download it. And I know of few companies who actually downloaded this project and adopted that for their own need.